Hey, my name's Naveen, and today I'm going to be talking about my glider project for a 1601. So, project requirements: the glider must be hand thrown, the glider must fit in a 16 by 16 inch box, the primary materials are supposed to be the provided balsa wood and just household items, and the minimum flight distance is 20 feet. So, design process. The inspiration for my design came from the smaller glider we built earlier in the semester. My original design was kind of similar to the small glider and just kind of scaled up and slightly modified. With the wing shape was slightly modified as well. But as I started making parts of the glider, I realized the original design could not be scaled up without running into some issues. I'll go into detail. So for the design process, like materials, adhesives, the main material I ended up using was balsa wood because of its lightweight and availability. Like we were given so much at the beginning of the semester. I also had to use some unidentified thin wood I found at the makerspace for the vertical stabilizer since I ran out of balsa. It was just some scrap wood I found in the back, but it was really thin and relatively lightweight, so I ended up using it. Adhesive. So I chose super glue because of how fast it dries. I considered wood glue, but I thought it was unnecessary since super glue would be strong enough. Also, wood glue takes, I think, almost 24 hours to cure, and I didn't really have a place to store it. Since I decided to use super glue, I also decided to reinforce it a little bit with duct tape. And then I used Play-Doh to manipulate like the center of gravity, and those are the main materials I used. I also used some duct tape to repair cracks in the balsa wood that happened after my test flights, which I'll go into detail later. So for the wing shape, I ended up going with a simple rectangular wing shape design. I was going to sand the wings down to create an airfoil shape, but my first test flight went well, even without this modification. Well, not my first test flight, but my second or third test flight went well, even without the modification, so I ended up deciding against it. If I had more time for the project, I definitely would have spent time like sanding the wings to create an airfoil. Wing placement. I tried different wing placements by taping the wings on with duct tape before supergluing them. The first one I tried, I think, was 3 inches from the front of the fuselage. For reference, my fuselage is 11.5 inches long. The best one seemed to be around 2 inches from the tip of the glider, so that's the one I ended up going with, and then I superglued it on. So the dihedral angle, this was kind of messed up, but I started with no dihedral angle, and for my design particularly, like this was like a huge mistake because after my first test flight, I realized the glider completely lacked stability. It did not really generate any lift at all. So I made a change to that pretty quickly. Tail configuration, I did not change the tail configuration throughout the design process. I know you're supposed to make the horizontal stabilizers point slightly downwards to generate more lift, but I found that I didn't really need to do that because the glider flew well even without doing that. So I just emulated the basic shape from the tail for the tail from the smaller glider. So longitudinal stability. So center of gravity is at the back of the wings. The way I found this was I just balanced it on that can right there of rose syrup, and that spot right underneath the wings near the back of it was the center of gravity. So I experimented with several different masses of Play-Doh at the tip when I was conducting my test flights. So this was that final shape is what I ended up going with, and that final mass is what I ended up going with, and that those seem to produce the best results for my test flights. The Play-Doh is also molded to be slightly aerodynamic. Just thought I'd do that instead of making it in a regular shape and messing with the weight distribution. So the coefficient of lift for my glider is 0.219. So the formula for that is just 2 pi times the angle of attack. I gave my glider a very small angle of attack, like 1 to 2 degrees. So I just converted my angle of attack to radians and then plugged it into the equation. Coefficient of drag. The formula for coefficient of drag is your coefficient of lift squared over pi times the Oswald efficiency factor times aspect ratio. So I ignored profile drag, I assumed the Oswald efficiency factor is around 1, and I got 0.00204. So design iterations, this was the first sketch for the design I made. So the fuselage in this design was very, very extremely thin. So it was more supposed to be, it was an attempt at emulating the fuselage design of the smaller glider. But I realized as I couldn't simply scale this up because my glider would be have to fly longer distances, and I thought it'd need to be heavier. So I changed this pretty quick. I made the fuselage a square. I just used the balsa stock that was provided. So that point 0.5 by 0.5 inch balsa stock became my fuselage. And yeah. Yeah, so the first physical glider I built used that design, used the balsa stock, and I made it 11.5 inches. And then the wings were placed on top of the fuselage instead of being attached to the side. And the tail design was just the same. The wood tail was just the vertical and horizontal stabilizer was just put on top of the fuselage. So this design iteration had no dihedral angle, and it made it very unstable. I had to modify the wings, the way the wings attach to the fuselage, by shaving down the edges of the wings to create a dihedral angle. So it's my final design. I just made a little SolidWorks animation. There's this little slit in the horizontal stabilizer. Both the horizontal stabilizers are one piece, and there's a slit in the middle where the vertical stabilizer can fit into, and I super glued it in. Final design. The wings are cut to be 7.5 inches long and attached to each side of the fuselage, which is 0.5 inches wide. This means the width of the glider is somewhere between 15 and 15.5 inches exactly, so it like barely fits in that 16 by 16 box on the right. Glider performance was good. It flew, I think 40 feet was my max distance. I don't think I had no complaints about that. I could have flown it farther if I made an airfoil out of the wings, but just time limitations. So final reflection, I thought this was an interesting way to test all the aerodynamic principles we learned throughout the course, and I had a lot of fun making it. Using the laser cutter to make all my cuts was fun as well, because I had to learn AutoCAD. If I had to do the project again, I would spend way more time on research, because I would have realized I needed dihedral angle, and also balsa wood cracks really easily. I had to make several repairs with duct tape, which is why my glider is covered in duct tape in this. And yeah, these are my sources, and thank you for listening.